video display capture. Okay. Okay. So welcome guys to a new live stream, and I think uh, my screen is visible. Let me check once. So, okay, so I am treating this live stream as a video, and for this specific live stream, I am going to cover a new project. Okay, and in this project, we are basically doing this building safety and monitoring solution. Okay, so for this project, we are going to use multiple AWS services from AWS IoT Core to Timestream database to Amazon simple notification service, and also DynamoDB, and also the AWS managed Grafana. Okay, or we can also do this the same using normal Grafana. Okay, that is a monitoring tool. So we will discuss each and every tool. We'll see the steps to set up each and every AWS services with this project, and what is this project, and I am also going to show you the demo for this project in this session. Okay, so so the next slide, the requirements for this project is that you need to have a Node.js software. Okay, so this is the software. You need to have this software in your machine, installed in your machine. And the second thing is an active AWS account. Okay, so that you can use services of AWS. So basically all the services which I am using in this IoT session are free. I'm using up to a free limit. Okay, so we will discuss the pricing things as well, because mainly when someone is switching to AWS, they need to look into the pricing. Okay, so these are the things we are going to cover in this session. So these are the only two requirements, and there is no need of any kind of sensor or microcontroller, because in the earlier session I have seen that uh, basically people need to follow my tutorial, so they always don't have these kind of sensors available with them. So basically we are simulating the sensor data using Node.js, using AWS IoT device SDK, so that we will see the flow, then we will understand what I am talking about. So in this session, what you will learn is basically the first point is the IoT core setup, IoT core create thing, attach policy, create attach policy, and then you can also how you create certificates, and starting from that you will publish and subscribe to specific topics. Okay, so that what you are defined in your policy. So that I will go through the in the next part. I will go through that step, and we're also going to set up a Timestream database in which the data coming from the sensor are going to store in real time. And what is Timestream? It is basically a time series database like InfluxDB. Okay, so Timestream is a database provided by AWS. It is just similar to InfluxDB. Then we have AWS managed Grafana. So basically, uh, Grafana is available, or is also available in AWS. Okay, so that this is the same Grafana we know that is used for monitoring purposes. Okay, so this Grafana we will see and understand this thing, that how we are creating things. And then we have the AWS SNS. SNS is simple notification services which we are using for generating the email and SMS alerts. Okay, then we have that AWS DynamoDB. Okay, so it is a NoSQL database provided by AWS, and in this database we are going to save the alert data. Basically the data which are generated due to some due to some threshold exceeds. Basically if a value is greater than a specific threshold, then we are generating an alert, and that alert data we are storing in DynamoDB. And at last we have AWS IoT device SDK. So this is a SDK provided in Python, also in Node.js also, but in this specific IoT session, I am going to cover basically in Node.js. So these are the agenda for this session, and the next part is the implementation part. Well, let's understand the implementation. Okay, then we will go through the demo. Okay, so first understand what are we going to implement, what is the project flow. Okay, so first step is that to capture the real-time sensor data from flame sensor, gas sensor, and water leakage sensor. So this step we are performing using our node.js script. Okay, so we don't have any real sensors, but we are simulating data. For flame sensor, we are simulating data between 0 and 300. For gas sensor, between 0 and 500, and for water leakage, 0 and 1000. So we are just generating random values between these range. Okay. Uh, okay. Okay. Okay, then we have the sensors. The sensors can be connected to the gateway. Well, after this step, what we are doing is we are sending this data, sensor data, with these random values to AWS IoT. Okay, so for that, what we are going to do is we will create a thing, and we will set up a we will basically using our node.js script, we are going to set up this thing to this node.js script. Okay, so this is a practical thing. Actually, I can't explain you in this language thing. When we are going to do this, then it will be more convenient for us to understand. Thus point B. So in point C, we can see ingestion of data from AWS. So now the data is at AWS IoT Core. Okay, uh, it would be much better if I can explain you from some diagram. Okay, so from Node.js script, we are generating data in this JSON format. Okay, so we are publishing this data to AWS IoT Core to a specific topic, which is basically thing ID slash telemetry. Then what we are doing is from AWS IoT Core, we have written some IoT rules. That is a feature in AWS IoT, a rule feature of rules. So we have written a rule that any data coming to this topic will be directly go to this AWS Timestream database. And for that also we have certain things which we need to take care, so that this flame, smoke, and water pressure, you can see flame 10, smoke, and water pressure in this JSON value, it should be inserted in particular table columns. Okay, so that we need to see how we are going to do that in that IoT rule setup. So there are three rules. The first rule is that flame value greater than 300, we are going to generate AWS SNS. So we are basically triggering the SNS service for email and SMS. And there is second rule for smoke greater than 500, and there is a third rule for water pressure greater than 1000. For writing these four rules, basically there is a thing in AWS which is called IoT SQL. So we need to write some SQL query so that we can perform these threshold things, so that this AWS SNS service will be triggered. And similarly, after this the data which we are receiving for flame, smoke, and water pressure, these exceeding data, these high data value which are greater than 300, 500, and 1000, we are going to store these data in AWS DynamoDB. Okay, so this is the flow which we are going to perform in this project. Fine. So starting from the node.js script, which is generating some random data for flame, smoke, and water pressure, we are storing it in AWS Timestream. Then okay, this Grafana thing is left. What after this AWS Timestream, the data is storing in a database. Okay, in the database we have that table, and there are columns on which these data are storing. And what we are doing for the Grafana is we are using AWS Timestream as the data source for Grafana. Okay, so we are doing that, and for creating the charts, we are using certain queries in Grafana that I will show you what kind of queries I have written. for written for showing the data in this manner. If you can see, this data is refreshing at every 5 seconds. Okay, 497, and I am generating this data 497, 260. Now it is 260. Smoke is 260. We can see where is smoke. Let's make this small. Okay, the last value is 260. So this is last flame reading, which is 5. Okay, so here also we can see 5 in the chart. So this is refreshing in real time, and we have the water pressure, which is 242, and I can see the same value here also. So this is the project, and what we are seeing in this chart, in this line chart, is the last 5 minute data only. After that, the data is getting pushed back in the left direction. Okay, so this is the project, and if I can show you, so this is the output of the project, and we will see for let's see all the steps one by one, starting from AWS IoT. So we are publishing data from this Node.js script. Okay, so here you can see we are publishing data on this topic TED / telemetry, and if we can see, we I have subscribed to the same topic. You can see my subscription. If I can show you again, subscribe to this topic, we need to wait. Okay, so there is a delay I have given of 20,000 millisecond, but for in real time it will be basically 7 or 8 seconds. Okay, so we will wait some time here. Okay, I can see a refresh. Okay. So once the value is console logged here, we will see the same value received on AWS IoT Core test console. Okay, let's wait for some. Okay, I can see one value generated. Yeah, 11, 425, and 211. So let me check the session. Mm, okay, my voice should be clear enough. Okay, so thing ID TED flame 11 smoke 425 and water pressure 211. Site 1 room 002. So what is the meaning of these two? I will explain that in some time. Before that, let's do one thing. Let's generate SMS notifications, SMS and email alerts. So the email should be generated on this email ID, and the SMS should be generated on this mobile number. Okay, so this is a topic which I have created in SNS service, so that we will explain it later. But for now, just for the demo purpose, I can see my email is open right here, and this is a 30-minute ago notification message is already there. So what I can do for generating a new notification. Okay, so if you can see, once the device is connected, I am publishing a data which is greater than 325. You can see that data which is greater than 300, and according to our architecture, we are generating the email and SMS once the data is greater than 300. So if we don't comment this line, if this line is effective, okay, so then this once the this script is connected to our AWS IoT, we will also we will going to publish this data. This script will going to publish this data, and resulting that we are going to receive the SMS as well as email messages on our subscriptions, on our SNS subscriptions. Okay, so let's do one thing. So for now it is running in a loop. Okay, but but this publish statement will run only when it is connected to, only in the starting, when it connects to AWS in the starting of the script. So let's close this thing and rerun this. So let me rerun it, connect it to AWS, and the data should be published. This first data, this message, this piece of code should have run. Okay, and how we will check, that it is run. We will check in the notification. You can see new message from IoT SMS. I can click on show, and this is 0 minutes ago, 7:51 p.m. Flame 325, smoke 38, 152. So this is the same. This is the same data, not from here. It is from here. 325, 38, 152. Okay. So and for the SMS, I haven't received yet. Okay. Yeah, for SMS also it should generate in some time, but for the email part, we have received the notification, and as per our flow, after this notification, we are also going to save this data, this piece of these three data in our AWS DynamoDB. So let's open AWS DynamoDB. Okay. So AWS DynamoDB version 2. So you can navigate to tables, and I have something which is a table which is called alert. So this is the main table. You can ignore this thing, alert table. I can click on it, then explore table items, click on this thing. Okay, and in this table I can see a single page of 1 2 3 4 5 6 items, and the last item I can see that the timestamp. So we click on this. This is the timestamp on which it is inserted to this database. Okay. So we can parse that timestamp into current time. So timestamp can be converted into time using JavaScript. So we can run that JavaScript in this console. Let me run that. What is the time it received on DynamoDB? New date of timestamp. So it is received on 15th May, 7:51:19. Okay, 7:51, just 2 minutes ago. The same time on which it is generated from this script. Okay, so we are good. So this data is stored here in this table which is called alert, and apart from that, okay, so we have covered this above thing. We have checked the email. We have received the email. Once we get the data, flame data greater than 300, the data is also get stored in this alert table. And if I can show you the schema of that table, I can see thing ID, TS, timestamp, flame is the column, room, site, and smoke, and there is also water pressure. So all these data get stored in this table. So the next step is that AWS IoT Core, AWS Timestream. So well, let's check if the real time data which is generating from here, is this data is getting stored in our time stream, and how is it getting stored? What is the format? Okay, so let's search it. Search here time stream, and there's the service AWS time stream. Okay, so we have in the time stream we service, we have a database which is called as IoT. Okay, and in this IoT, you can't like explore any table. Okay, you can't do that. Let's see some metrics. Okay, so there is these are my metrics, but the thing is that if I even open this sensor, in the database, in the IoT database, we have a table which is called as sensor. Okay, so in the sensor table, to explore, to get the data out of this table, we need to use query editor. Okay, so query editor is there. So okay, so there are few statements already saved for me. So let's do one thing. Let's take out all the data from sensor table which is in IoT database. So let's remove this backspace. There is no need to add a semicolon. Okay, just click on run. Okay, if you can see, there are 33 pages, and for each pages there are, I guess there are 10 records. 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, more than 10 records or 15 records. So there are actually total 330 records which are returned. So for the 33th table, I think this is the real time. But you can see there is 14:25. This time is not the IST, Indian Standard Time. What I was thinking is this is the GMT. Okay, so the current time minus 500 5 hour 30 minutes. Okay, so that is GMT, and for India time we are 5 hours and 30 minutes ahead of the Greenwich Mean Time. Okay, so if I can show you the data how it is, you can see water pressure only. So the last water pressure value is 3. Okay, so it is this value. Okay, and other than the water pressure, all other values are also there. Okay, but the format of storing the measures, these are stored as a measures. Okay, so if you can see flame is also there, and all this data are there, but few of them are static and few of them are considered as measures. Okay, so it is just like the points in influx gb. Okay, so the similar case, but well, we will understand this point more clearly when I am creating this database tables and setting up this database. Okay, then in that step I will going to set up this measurements, all the things. Okay, so that is all for the demo part, I guess. I think okay, from AWS Timestream we have the Grafana, and if I can go here, Grafana. Okay, let's do one thing. Since it is getting more load on our server, so let's turn it off. And now what we can do is we can click on edit and see what kind of queries are there. Okay, uh, well, before okay, so explaining this query right now will not make much sense. So what I was thinking is that we will go in a flow, so we will go step by step. Okay, so starting from step 1. Okay, the A, then B, then C, D, and E. So these are the 5 steps I need to cover in this session. So before covering each step in detail, let me go and come back for in 5 minutes. Okay, let me turn off my video capture, turn on this image, turn off. So I'm back, and let's start with creating a thing in AWS, and so that can follow our follow our implementation steps. So starting with so first step is that after logging into the AWS, you need to search for AWS IoT. Okay, so let me show you that also. You can see AWS space. Okay, so I am already in AWS IoT, so it is not showing that for me. Okay, well, but in your case, once if you are in in the starting, you can search for AWS IoT. Okay, so if I will navigate to this link. Okay, so you can see in my AWS management console, I'm here. After logging in, you are also will be here, but in your case, you will not see any of the services here. So for IoT core, you need to search for IoT core, IoT space. You can see IoT core. So click on it. Okay, so here is the welcome page for IoT core. So you need to go click on this connect, or you can simply go to manage things. Okay, so first step is to create a thing. Okay, so I already have one thing TED, but I will create a new thing so that you can also go through the steps. So the before going any further, what I want to tell you is that there is a thing which is present in this console, which is a new console experience. Okay, so if you don't have any experience in this thing, so you kindly turn it off. Okay, to change, save or cancel your changes, dismiss. You can change the console or where you aren't creating or editing a resource. So I need to go to the back page where I am not creating anything. So here, first turn it off. Okay, so it will give you unnecessary errors, okay, or bugs while doing things if you are working on the new console experience, because there are still some bugs are there. I have used things. Okay, so that's why I'm suggesting you that turn it off, okay, before creating anything. So first click on this create thing. Okay, so here we can create a thing which is basically uh, which is representing a gateway for us. Okay, so a gateway like Raspberry Pi, a Raspberry Pi is a gateway for us, and for for that gateway we are creating a thing in AWS IoT. Okay, so this is a thing which is representing our Raspberry Pi. Okay, so create a single thing and create many things. Okay, so for this purpose, for tutorial purposes, I am creating a single thing. Okay, so click on next. So first it will ask thing name. So I can name it Raspberry Pi or simply Raspberry Pi. Okay, and there are other thing types is there, searchable thing attributes, thing groups. Thing groups is very important in cases where you can, if you want to create certificates and policies for not for just one thing, for an entire thing group. You want to apply jobs on not one thing to the entire thing group. If you want to do all those things, okay, so then you need to use thing groups in your project. But in our case, we are not going to use that kind of thing, that kind of operation, so we are not using thing group here. Device shadow device shadow is not needed. Okay, so we can ignore this. Okay, but in most of the cases, device shadows are very important thing, because these are the reserved topics. Okay, so these are very reserved topics in AWS IoT, uh, which help us in getting the state information. Okay, state information of that thing. Is it online, is it offline? There are specific topics for that, for getting all those kind of data. and also we if we need to update some kind of device state to that topic, okay, in form of JSON, and we want to retrieve it, and if there is some change in that data in the state, we will get a notification. All those kind of operations we can do using device shadow. And this, I think I already explained it in one of my previous AWS videos, okay. So that's why I am not using device shadows in this session, okay. So for now what I can do is click on next. Then we have device certificates. Auto generate is the recommended option, but there is also option for user certificate signed by your own certificate authority, so CA. So for this one, the CA certificate authority will be Amazon, okay. But if you want to generate using OpenSSL software, generate the certificates using that OpenSSL as a CA in your system, okay, that generated certificate can be used, okay. We can use CSR register RCSR CA here. So all the options, all the other options are also there, but as a easy one, we can use auto generate a new certificate for this thing by AWS as a CA, okay. So click on next. Then the policy. So policy, I have already explained in the previous video. I already told you about. And for now what I will do is in this session, because there is some limitations on time, okay. So that is why I will create a policy, but the resources which I will allocate to this thing is entire, like all the resources. Policy name, let's name it Raspberry Pi policy. Raspberry Pi policy. Then we have the builder JSON, okay. So allow is there, policy action, all AWS IoT action star, policy resources. You can make it a star, like every resources, everything can this thing can access all the resources of AWS IoT of this account. Okay, Raspberry Pi policy, and now we created this policy. Okay, so the next step is to move to tab, and now you can see the policy which I have created in this tab is reflected back in this tab also. So I can select this one and click on create thing, okay. So there are a few things which we need to download so that we can connect to this thing, so our Raspberry Pi can connect to this thing. So what we need is basically private key, and we need the private key and device certificate, and root CA certificate also we need. We can easily get it from the documentation, but it is easy to get it from here. So this is the first thing we need. The private key is the second thing, and device certificate. Okay, okay, deactivated. Okay, sorry. I need to click on download. Okay. So first, second, and three things I have downloaded. Okay, but it is suggested to also download the public key. Okay, so you can also download this. Okay, perfect. Now what I can do is Amazon root CA1 is also there, so click on done button. Okay, you successfully created a thing, and also the certificate. So I can see the Raspberry Pi, okay, I can see Raspberry Pi, but where is my certificate? So for checking the certificate, we have the secure tab. In this is the certificate we have, okay. And the certificate is 15th May. The above one is the latest certificate, and this certificate, if I click on it, you can see the policy attached to the certificate. The thing is attached to the certificate, okay. So everything attached to things deattach. Okay, it is attached. Perfect. So everything is now connected. The thing is successfully created. The status is active. The certificate is in active state right now. And when is it expires? When this thing will expire? It will expire in January 1st, 2050. Okay, so we have enough time. Okay, so just kidding. So okay, so now what we can do is, if I can, okay, okay, let me do one thing. Let me open the my AWS SN folder. Okay, perfect. So here, this is the code which I have already written TED for TED as a thing. But now the thing name is Raspberry Pi. Okay, so I need to delete these two. So I simply click on delete, and I need those two certificates to this location. To this location, I will share this code. Okay, I will share this JS file, and you need to you can easily run this thing. Okay, so let me do one thing. Let me turn off my screen capture so that I can navigate to my downloads location and get the file to this location. Okay, so we can do display capture is there. Turned it off. Okay, so there is a certificate pem.crt. This one is the certificate, and pem.key. Although you can't see my screen, public.pm.key is the public key. Okay, which we are not needed, which is not needed at all for creating to that, for connecting to that thing. So private.pm.key, the ending with this thing, and pm.crt, these two things are needed. So just I copied this and pasted it the code directory, and let me turn on the screen now. Okay, so these two I have, you can see pem.crt, this one is the certificate, this one is the key. So, and sdk underscore alert.js is the file, the script which is generating random sensor data. Okay, so for the key path, for the, okay, let me turn this off. For the key path, I can see, rename it, copy the whole name, and we can paste it in the this location. And for the cert, this is the certificate, rename it, copy it, and paste it here. Okay, then you also need to change the host. Okay, in my case, I'm not changing, but in your case you have to change. The reason is that this AWS IoT is basically a broker. Okay, MQTT broker. So you need, so for every person there is a separate broker link. Okay, so for me, this is the, in AWS settings, I have navigated to the last, and in settings I can see the endpoint, and I need to paste it right here. Okay, so this is how we have defined the credentials of our thing, which is the thing name is Raspberry Pi. Okay, so uh, the next step is, let's starting from this script. Let's understand how this script is acting. So AWS IoT, we are importing this AWS IoT device SDK. Okay, we are importing from here. I can't see package.json in my in my repository, in this code repository. I can't see that package.json. Uh, but I think I need to add that thing and create it as a standalone node project. Okay, so that is missing in this repository, and after I give you package.json, you can easily do the npm install thing, and install this AWS IoT device SDK library. Okay, so this is a node package. So for this package, I can see it is defined, it is initialized using these 5 parameters. Okay, so now we have the device as a variable, for in which we can access all the actions, all the AWS IoT actions we can perform using all the functions we can now call. So first of all, the function is connect function. Okay, so this is a callback function, and in this I can see uh, uh, we will the script we will it will call this function once the thing we are this script will be connected to the AWS broker. Okay, so then only this callback function will be called, this one. So after we get connected, so there is no such thing of subscription here, although we know that in MQTT there is a thing of publish and subscription for receiving the data, if we are receiving the data. But for this specific script we are only sending the data with a specific interval. Okay, so what we are doing is, let's ignore this step right now. So I commented it using a double slash forward slash. Okay, there is some time. Okay, so okay, fine. So there is one function get random arbitrary lower upper, and there is another function which is my timer, and there is a set interval which is a common JavaScript function for running this callback function every 20,000 millisecond. Okay, that is the meaning of this one, this line. So we have this single line, and this single line is running this my timer function every 20,000 millisecond. But in real time this is not the case. This time will be much lesser, around 7 8 or 10 second. Okay, not to 20 second. So okay, so for my timer I can see I have one data as a object, JavaScript object, and I am filling this object using these keys. So I can see there are two keys which are static in nature. Okay, and there are three keys which are dynamic in nature. Okay, so these dynamic data is generated using random functions. Okay, so there is a in like in Python we have also math random functions in JavaScript. And how I am generating is that uh, if I can show you the architecture once more. In the architecture you can see that the flame value is greater than 300, then we are making it as a threshold value as a 300. So any value greater than 300 we are generating SNS and saving it in our DynamoDB table. So but in this case what I am doing is generating value less than 300, so 0 to 300, and 300 is not inclusive. Okay, so this upper limit is not inclusive, so data will be generated always 0 to 299, 0 to 499, and 0 to 999. So this is how these three data generated, and this is a very common function. I can make you understand this also. Okay, so this math.random will generate data from 0 to 0 point not 0 to 1 basically. Okay, so data will be generated from 0 to 1, and using this math.floor function will take the lower value and adding the lower value to the difference of upper minus lower to the plus into the difference. So if you do the all the calculations and take an example out of it, you can easily understand that. Okay, so I will not go in deep for this specific line of code. Okay, so let me check my voice quality. Okay, okay, everything looks fine. Okay, now the next step is that everything I can see everywhere it is ted written around, but our thing name is Raspberry Pi. Okay, so I need to replace it everywhere. Okay, so what I can do is right click on it. Okay, and I think let's make it Control F. Okay, and you can see replace, find what ted and replace with Raspberry Pi. Okay, so replace all is there, so to just click on it. Okay, so connect. Okay, Raspberry Pi slash telemetry. Okay, water pressure, site, room. So what is these two things? What is site and what is room? So these are very important things. So what I was Control S. So what I was doing is that we are generating we are working on the gateway in a specific room of site 1 of factory number 1. So this solution, if we in a larger scale, if we are thinking for in a larger scale, if we have multiple factories, multiple sites, then the data which is generated from this gateway will be installed in one of the room number 002 in one of the factory. So these two data are showing that kind of information. So okay, so these are very important thing. Okay, so what we are doing is we are not focusing on the topic. We are like sending data directly on thing name as specific device id, which will be distinguished, which will be different. Okay, so this is a unique thing slash telemetry, simple thing. But in real case scenario, there is more discussion, more knowledge. We need to invest more kind of things to get this topic. So like for let me take an example. So in if we don't follow this kind of json architecture, okay, if we don't follow this kind of json architecture, then I need to create topic in such a manner that it will represent that room of that site. Okay, so I need to like do something like site 1 forward slash room 002 forward slash thing name slash telemetry. So this is the architecture I need to follow if I will remove these two lines of code. Okay, so this topic, either you will represent the same thing in JSON structure, or you can do the same thing in topic. So this is the meaning for that. And you can see device dot publish after the JSON is created using these line of codes. Okay, after the JSON is created, what kind of JSON I'm talking about, let's turn it off, control C. Okay, so after this JSON is created using these line of codes, we are basically stringifying it. Okay, make converting this JSON into string, because for the syntax of device.publish, the first argument should be string and the second argument also should be string. And we are also logging this data in the console, on the console, as you can see on this screen. Okay, so that's all. These are the very simple line of codes. Okay, so I have also written the same code in Python also, but for some reason, but for some reason it is not working. So I will share the code in my GitHub repository if anyone want to fix this code and make use out of it. With this I have written using Paho. Paho is a MQTT client library for connecting to a MQTT broker. Okay, so in this case MQTT broker is AWS IoT Core. So if you can see, I have written one sketch where in a loop with a sleep of 10 seconds, I am creating this JSON structure, converting it into string, then publishing it with a quality of service as 1. Okay, and logging the same in the console. But for some reason we are not able to work. This script is not able to work. Okay, so if you can see, there are few things which needs to be noted, like the broker address and the broker and the port also. Okay, so that port is 8883. Okay, that is the default port for MQTT over the WebSocket TLS over. Okay, over TLS MQTT we have 8883, and this is the default configuration for AWS IoT AWS IoT. Okay, so that these are kind of details you can't see in this script, because in this script we are using the code which is internally written. Everything is already written by AWS IoT developers. So we are just simply calling functions and working with it. So that is all from this part, and let's do one thing. Let's run this now. I have saved this. Okay, these are updated only, and these are also updated. Okay, so the next step is to run it. So running it using Node. So you need to have Node.js installed in your machine. Okay, and how do you check if it is installed or not? Simply node space minus v. I can see Node version 12 is there. Also check npm version. Node package manager is npm. Okay, 6.14. So Node is basically like you can see as Python, and npm is basically pip. Okay, Python package manager. So simple things. So these are there, and okay, so we are working on JavaScript. So let's run this script now, so that we will see the data which is getting pushed for the thing Raspberry Pi. So connected Raspberry Pi to AWS. So we are this Raspberry Pi thing is now connected to AWS. Okay, and if we can see, there is this test thing which is a test client, MQTT client, which is present in AWS broker, so that we can do some testings. Okay, so click on this subscribe to a topic. Okay, so before clicking on it, I think we need to write the subscription topic here, which should be Raspberry Pi slash telemetry. Raspberry Pi slash telemetry. I need to subscribe it, and I can see I am receiving the data. Okay, so you can see that this is the data which is received: 0021 111 and 289. So these the data is still we are receiving the data. Okay. Yeah, second data, perfect. So till this point we are connected to AWS IoT Core, and we are publishing this data to it. Okay, now the next step is to write IoT rules for generating email alerts and for ingesting data into AWS Timestream. Okay, so first I will do the fourth rule. Okay, so let me do that. In Let's close these. In act I have rules. Okay, so I can see there are a few rules already there. Okay, but let's do one thing. First, there's one disabled rule I can see. Let's delete it first. Okay. So for creating a rule, you can simply click on this create and ingesting data ingestion into time stream. So let's name it rule 4, as I can see in the architecture. For ingesting data, there is no need of description. Okay, there is no need of description. So rule query version. So for now, let's leave it as it is. The version as this 2016. Okay. So the rule query should be select star from topic. So this is the IoT SQL which I was talking about in the starting of the session. So all the data, this all data coming on this topic, coming on which topic, coming on this topic will get ingested to our time stream. Okay, so how we are setting up measurement is another thing, but all the data should get captured here using this line of SQL query. Okay, so this are this is the first step. Then set one more action. Okay, now we need to add an action for this. So if we receive the data, then what should happen? So I need to click on add action. Then I can see time stream right here in the last. Select it, configure action. Okay, so database name and table name. In your case you can't see anything if you haven't set the database or table earlier. You will not able to see anything, but for me I have this database IoT and table as. I need to select IoT, then I can see that table sensor inside this database. So first I need to create a new database. Okay, so let's create a standard database. Click select this one instead of sample. Okay, so name should be so IoT is already there, so let's name it IoT 2. Encryption is already AWS slash Timestream. Okay, let me turn off my PLC video capture. Oh, not this one. Okay, let me see. Image. Okay, PLC video source. Turned it off, and video capture device and my Okay, so okay, I'm back. I got a call, urgent call. Okay, there. Okay, fine. So where are we? We were okay. So we are creating a database, a time stream database. Okay, so this time stream database I already discussed. This is a time series database. So we you need to in the configuration, you need to select standard database IoT2 as a database name. I am selecting here. Okay, then KMS key. Okay, so KMS key is already AWS forward slash time stream. Okay, don't like leave it as it is. And tags, there is no need to add any tag. So that's all. Create database. Okay, perfect. So a database is created. So what I need to do now is inside this database I need to create table. Perfect. So that is a simple structure. Inside this database I can click on this tables. Okay, sensor table is there inside IoT database. So I will create a table, a data inside database IoT2. I will create a table name sensor2. Data retention. Okay, so data retention is how long is data retained in storage tier. Data moves from okay, so uh, select this very carefully because these might affect your pricings. Okay, so select this carefully. For now what I have to select is uh, there is a time frame already. Okay, so I will select memory retention is 12 hour only. Okay, for magnetic store retention. Okay, so this I can select for like minimum is 1 day and I can select 7 day. Okay, so 12 hours and 7 days as magnetic retention and memory store retention. So that is all I need to do for creating a table inside a database. Create table. Sensor 2 is created in IoT2. So that is all for here for this page. We will come back to this page, and if I click on this refresh button, I can see IoT as well as IoT2. So the database is IoT2 for us, and the table is sensor 2 for us. Okay. So now the next important step is that select dimensions. Okay, so each record contains an array of dimensions. Minimum one dimension represent metadata attributes of a time series data point. Okay, so these are metadata attributes of time series data point. So time series data point we don't need to add those at all in the configuration part. Okay, so we need to add the metadata. And what are the metadata? So metadata are the like data information. Okay, so for this specific data, where is it coming from? It is generating for room 1, for site 1, for room 002, and the thing ID is this. So I will consider these three data as metadata. Okay, so dimension name as thing ID thing. Okay, it is already here. And dimension value. Okay, dimension value I can set as Raspberry Pi. I can't type. Okay, now I can type Raspberry Pi. The second dimension is metadata is site, and the third is room. Site 1, site 1, and room 002. Okay, the next step is timestamp. Okay, okay, okay. So these what I have done right here is given these data values as static data, but the thing is that these values can be different. Okay, so for the site 2 I will write another node.js script in which basically there should be another gateway which will generate data for another site. So this can be dynamic. These values can be dynamic for the second site. It will be number 2, and the room number should be 3 for the third gateway. So it is generating from the gateway which is placed in room number 002. So the thing is that we need to make this thing as dynamic, so that we can do using simple JavaScript. Okay, so like this. So if you have basic knowledge of JavaScript, you know that this kind of approach is there, in which the data which is present inside backticks. Okay, so these value, the actual value inside it can be considered here. Okay, so it is not considered as static. So for site, I have one site variable. Okay, these are actually internal structure of time stream. So I have read some documentation to understand this thing. So like this, so you need to define it like in this manner. Okay, perfect. So now this, you can see timestamp include value and unit. I can ignore it. Let's see. Let's try to create. Okay, before creating this, I need to create a AWS IoT role. Okay, this is a IAM role. So I need to create one role which will basically have access to this specific database, time stream database. Okay, so I can create a role IoT to roles, IoT to time stream role. We can see time stream role. To access this, this is the role IoT to time stream. There is no need to put role and create role. Okay, and it is attached now. And let's try to add this action. Okay, it is added. So this is the IoT SQL query, and this is the action time stream database. So all the data coming on this topic will get ingested to this time stream IoT to database, sensor to table. That is all. That's all. So this is the rule data configuration we have done, and we can click on this create rule button. Successfully created, and I can see rule 4 here, and but can't see enabled here. So the reason is that still AWS IoT has some faults. Okay, so there are still some bugs. If I refresh this page, I can see enabled. Okay, so there are few bugs, but you can ignore it. Okay, so there is no need to worry on that part. So rule 4 is created, and let's stop this thing. Okay, and let's go to this sensor tool which we have there. Let's see if there is any data query editor. IoT select star. Let's use this. Okay. Choose a database to query. I will choose IP2 and write a query. I can't write for some reason. S. Okay. S. Okay. See, measure name and timestamp. Measure underscore name and timestamp. There are two columns. Okay, so these are the default columns for our table. Okay, so let me try to go to this tab and write. Okay, I can write now. Select star from IoT 2 dot sensor to run. Okay, I can see one value. Sorry, I can't see any value. So there is 0 rows affected. Nothing is returned. No table details. Output 0.00 byte of data. 0 rows affected. Okay, so for till this point, the data ingested data is not yet inserted in this table. So what we need to do is we need to start this script again, and let's check if it is inserting or not. Okay, so let's wait here till a first console is logged, and I will see my rule here. It is in. Okay, Raspberry Pi slash telemetry looks good to me. I can see my previous rules. If you can see, okay. For my previous few rules, I can see I have only inserted these three values. Okay, so these three values I have only inserted. Okay, so let's see. For the new rule which I have created, I have used the star for basically all the columns, and by columns I mean the all the keys of the JSON message structure. Okay, so I can see there are two values already there inserted. So well, what we can do is we will run this query again. Okay, I can see there are few values. You can see vacant, varchar, smoke values are there. Smoke values are there. Site, roam, uh, measure value, begin and measure value, varchar. Okay, let's 18 rows were returned. Now 30s, total 30 entries are there. Okay, so what we can do is instead of the in the rule, I think I have made one mistake. Okay, so that we can fix easily. That thing we can fix. First thing is we need to disable this rule before working on it. Let's disable this rule 4 and let's edit this rule. And in star, instead of star, since we are only capturing, we need to store the values uh, which are related to time series. Okay, so which are actually related to time series. So this site one will never change with respect to time. Like for the next second, it will not never be 2. Okay, so that we need to take care, and I need to only ingest the flame, smoke and water pressure. Okay, flame, smoke, water pressure. Select flame, smoke, water pressure from this topic. Update. Can't see any save option. I think it is saved. So that's all. So it is disabled till this point, and now click on enable. It's enabled now, and we can turn this on. Okay, so for now I can see 30 rows are were there. So let's do one thing. Let's truncate. Okay, let's truncate table trun truncate table this. Okay, let's delete all the entries and everything. Run. Okay. Query syntax index syntax error. Okay, let's try delete command. Delete from table where true. Okay, delete from this table where the condition is true. Everything. Let's try. Okay. Okay, let's leave that thing aside, and okay, there is the syntax error. Okay, wait. Select star from IoT to sensor to. Okay, let's check the latest data. Okay, now the 45 entries I can see. Okay, for smoke, only smoke data in the first page. In the fifth page, water pressure. Fourth page, flame. Flame is 26,730. See, 26 I can see. Okay, so flame value at this timestamp is 26, which is get stored as a which is stored as a row. Okay, so you will ask that why are we not using multi records? Okay, so that is a thing of another session. I will explain that thing in next session. at how we are going to store all the time series data, all the records for a single timestamp, which means basically flame, water pressure, and smoke. All these three will be have some value for a certain timestamp. Okay, so that thing is not you can see here. What you can see here is that flame is there, although the time is almost same or equal to same. Okay, so for this specific time, I will also get a smoke value and a water pressure value. But the thing is that all these things will not be present in a same row. Okay, so but there is that multi-record feature which is available in Timestream database. Okay, so that I will make a separate session for that thing. Okay, so for the fifth page, or let's modify this query. Okay, so we can use a limit and also the decrement like the last values. See, limit 10 records only for last 10 records. These are the last 10 records in decreasing order, like decreasing order with respect to time. Okay, I haven't mentioned that. Okay, this dscy time, so I need to group by time. Time is the column. Okay, this is the column. Group by not group by, order by. Okay, order by time in decrement order with limit of 10. So last 10 records with, okay, I can see now 306, 773, and 26. Let's see. uh, I can see 26 here. 773, 242, sorry, 242, smoke 242, 191, 242, 191, and 306. Okay, so this is the query I have written for getting the last 10 records in decreasing order of the time. Hope you understand this point. This is a very simple SQL thing. If you have some knowledge on SQL, you can easily understand this part. Okay, so okay, perfect. So this is what we need to implement in Grafana side for getting the last data. For if you have seen my video in the demo part of this, the starting of this session, you have already seen that in using the gauge we are showing these three values. So we need to implement this kind of logic in Grafana. Okay, so before going to the Grafana, although the next step should be that we should go to Grafana after AWS Timestream. But what I need to do now is I will cover these IoT rules and complete this AWS SNS and DynamoDB. Okay, so already I think I am already out of time right now. So this is the maximum time I have saved for this session. But I think there should be like 30 minutes or 1 hour more. I need to work on that. I have to extend this session by 1 hour. Then only these SNS, DynamoDB, and Grafana will be covered. Okay. So time stream we are already covered. Okay. So IoT core also the script that this script we also covered. So these things. Let's start from the start creating from rule one. These three rules. Okay. So here water alert, smoke alert, fire alert. So these rules are already created, but let's create three new rules so that you can also see how to create rule for SNS for triggering SNS service, SMS email service. Okay, so let's make it as a fire rule and the rule definition, the SQL query for that. How we want to trigger the action. Okay, so for triggering this action, what I want is that select star. uh, okay, select star from IoT slash topic. Okay, so I need to update this thing at least, where flame greater than 300. That is all. So select star from Raspberry Pi slash telemetry where flame is greater than 300. When will this query will execute? Once a value greater than 300 will be sent to this topic, then only this IoT SQL will run. Okay, hope you get this point. So very simple. Then add action. Then I can see SNS, where it is. Uh, okay, it should be at the starting. Send a message as an SNS push notification. You can see, we'll select it. Store a message in a Amazon S3 bucket. Now the new services are also introduced here. Earlier it is not there. So let's ignore these things. Let's configure this SNS. Okay, so for configuring SNS, we need to create a target. And what do you mean by target? Target means SNS topic. So I need to create a topic. Although I can see there are two topics, but in your case it will be not there. Okay, so you have to click on this create button, create a topic. Let's name the topic as notification. Simple notification. Create. It is selected. Message format, raw or JSON. You can select raw here. Choose or create a role to grant AWS IoT access for this notification as a notification topic of SNS. Okay, so I will suggest you to create a role for this thing also. Okay, so you can simply create a role for this specific resource notification. uh, Notification role, create role, and add action. And this is the things all. Okay, so that is all here. And you have seen my AWS notification, you can see that there's a TS also there, but we are not sending TS in my JSON structure. I am not sending TS. So how this TS is coming? So we can generate this TS from here. Okay, so for that, what I need to do is I need to TS as timestamp. Uh, as timestamp, I guess it is a timestamp. I need to check in IoT SQL is it there or not. AWS IoT SQL. Okay, so this thing timestamp function is there, not timestamp. That's all. So select star comma TS as timestamp. What is TS as timestamp? And star coming from the here. So this is the total query for generating a message like this. So click on create rule. Okay, failed to create rule, unexpected token. Let's see. Select star comma TS. Greater than 300 looks good to me. We'll try again. Okay, so instead of wasting time, let's see that how I have created it earlier. Okay, so I have already created these things without any error. So click on fire alert. Okay. Star, comma, okay, okay. I am doing that thing in reverse order. Okay, my mistake. Okay, timestamp is the data actually is timestamp. TS is not nothing. Okay, so yeah, we are converting this. We are taking this as a TS as a column name. Okay, so timestamp is the real data. Okay, which is the current date and time. Current date and time, not current date and time. Current timestamp. Okay, in millisecond, or I think it is in, yeah, it is in millisecond. That is all. Create rule. So you can see the fire rule is already created now, and actually you have we have already created that topic, topic notification, but we haven't added any subscription. That what will happen if some message will published on that notification SNS service. Okay, so I need to go to SNS service separately here. Okay, okay, though it is opening. Yeah, so there are three topics. So notification is the topic we are working on. So we haven't have so we don't have any subscription. So what will happen if the message will be published on this notification according to that rule? So we need to create subscription for that. And protocol I will select. So you can see there are multiple protocols. What will happen? We can send AWS SQS, Kinesis data firehouse, Lambda function. We can trigger. Okay, Lambda function is very important. Okay, so using the Lambda function, we can what we can do? We can modify this message format. We can modify this message format using AWS Lambda function using that. Okay, so but for now we are good. For now this message format is good. If you want to uh, structure this message format, we can use Lambda functions, AWS Lambda functions. But for now I will choose email. And what is the endpoint? So I will choose my email ID, Jignesh A19978 at the rate gmail.com. Or I can select that test one. Okay, instead of this one, because it is not yet there. I can see this test mail 9958. Okay, test mail 9958 at the rate gmail.com. Okay, so okay, I can see this endpoint. So once we get that we get any message on that topic, an email will be generated with the data. Okay, with the raw data which we already conferred in the which we already configured in that IoT rule. Okay, the raw data, not in JSON format, in the raw format. So these are the things. And create subscription. Okay, so you can see a green success message. Cross it, go back to notification. Now you can see that notification, but still I can see pending confirmation. Why is that? So we need to go to our email ID, Gmail ID basically. Okay, you need to open that and confirm this thing, confirm this SNS topic subscription. Okay, so click on it, confirm subscription. Yeah, subscription confirmed. Now I can receive the notifications. Okay, so yeah, so if I refresh this page now, I'm done with my setting up my AWS SNS service. You can see confirmed, protocol is email. Similarly, I can also add mobile number. If you have already seen that in the protocol I also have SMS, but for SMS, before adding that, what I need to do is I need to add I need to, in the SMS I need to add that mobile number, verify that mobile number using the OTP. Add the mobile number and verify it using OTP. So that process need to be fulfilled first before adding the subscription mobile number under the subscription. Okay, so in the notification as a topic we have this subscription for this email, and we have added for fire. Okay, so we have added the rule for fire for flame data greater than 300. So let's do one thing. So what we can do is we can uncomment this and send a flame fire data greater than 300. Okay, so before that I need to check session. Okay, it is fine. So 325, let's make it 558 and save it. And here I need to stop it, rerun it. So it is connected, and as soon as it is connected, the next thing will be this code will run. This line of code will run, and as soon as this will run, our fire IoT rule will get triggered and an email should be generated. Okay, so we will see, we will refresh. I can see in the promotions, I can see an email at 9:12 p.m. Okay, so 558 is that data, right? So okay, let me close this, open it, not this one. Yeah, here claim data is 558, which I have sent, and this is notified here in the email with TS as a timestamp. Okay, so this we have seen this fire data, and similarly, let me create for smoke and water. Okay, so let me do that. I can simply duplicate water and smoke. It is possible. Okay, it is not possible. Fire, water, and smoke. Okay, smoke is the rule name. Then topic star comma timestamp as TS from the topic. This one where this is the rule for smoke. So we need to we need as per our architecture we need to apply this rule greater than 500. Okay, so that is all. Add an action, SNS, configure that action, select the SNS target, which is notification message format should be raw, and role we already created, which is notification role. Okay, so add an action here and create the role. So fire is created, smoke is created, now water is left only. So let's create a rule for water leakage. Water star comma timestamp sts from Raspberry Pi slash telemetry, where uh, water underscore pressure. This is the this is the data which is receiving here. So that is why we are using this as this name, uh, greater than 1000. And for this action, the same similar manner, SNS. Okay, topic role here, notification, and add action and create a rule out of it. So three rules are created. Now we are going to create one rule. We are going to create one extra rule which will basically send the data to AWS DynamoDB. Okay, So similar to if you can see time series store, rule 4, fire, smoke, water. If water, okay. So I think I have deleted that rule. Okay, so that is not a problem. So what we can do is we can create the DynamoDB rule for ingesting the alert data to dynamo dynam db alert data to DynamoDB. So this is the rule. And so okay, okay. So instead of creating separate rule, what we can do, we can add the DynamoDB action like to these three rules: fire, smoke, and water. So every time these are triggered, these rules will be triggered. First action will be performed as that SMS and email alert will be generated, and the second thing is that the data will get inserted in the DynamoDB. So let's do that. So let's add another action which should be that split message into multiple columns of DynamoDB. So configure this thing. So in the starting, for now I can see there are tables, but for you there will be no tables. Okay, so what you can do is okay, so for this what you can do is you can create the table. Okay, let me see the live stream. For now it is fine. So we need to create the table. Let's see. So if I can go to this tables tab, I can see alert is already there, storage is already there. So let's create a table name as alert2 and partition key. Okay, so there are few things which you need to understand here. What is the partition key? Is the part of table's primary key. Okay, it is a hash value that is used to retrieve items from your table and allocate data across hosts for scalability and availability. So in this case, in our data case, what you think is the primary key? So in the normal database DBMS approach, we will consider the unique value, a unique value identify which can identify a row as the primary key. But in this case, in DynamoDB, it is not the same. Okay, we don't need a column with a unique value. We don't need that. Although we don't have also, I can see there is no such column which is every time unique. uh, it is possible that flame is 53 here, also flame is 53 here. So it is possible. So what we can do is we can simply use thing id as our primary as our partition key. So it is not exactly the same as the primary key, so we can use thing id. Okay, so what thing id is basically it will be different for two or multiple things. Okay, so you need to understand this part. If we have multiple gateways, for one gateway we are using this table, or using this partition. Okay, so partition you can understand as a table. So for another partition it will be another unique key. So that is the reason why we are selecting thing id as our unique key for this table. For another gateway we have another table, and that will be different. For that we have a different thing id unique key. Okay, so you will understand this thing now. Partition sort key, what should be sort key? Sort key we can use a ts. Okay, so what is ts? I can't see ts here. I can't see ts here. But when we are creating that iot sql statement, I am using timestamp function for creating another column which is called as ts. And there is a number actually, that is actually number. What number? It is a timestamp actually in millisecond. Okay, so this string id is, I can see this is a string. Okay, TS is a number. Setting default customize, use customize settings, because you need to create table in such a manner that pricing is also not get affected. So you need to take care of that. So for that you need to use provisioned read capacity, and auto scaling you need to turn this off, and provision capacity you need to make it 1. Okay, so these everything I'm doing this, and see, you can see $2.52. Okay, make it 1. Now you can see $0.59 per month. So that is the reason you need to turn off the auto scaling and make the provision capacity to the minimum, which is 1. So okay, so this is how we have created a DynamoDB table alert 2 with partition key. The reason for partition key I have also explained. If you have missed this part, like, go to the previous 5 minutes of this video and see that. Simple. Okay, and now I can see secondary index estimated cost $0.59 per month. Okay, perfect. This is the minimal cost I can bear. Okay, and encryption at rest owned by DynamoDB. Don't change. Simply click on create table. So it is creating right now alert 2. So we will, after it is created, let's wait. Sort key is there, partition key is there. Okay, sort key, the meaning of sort key I haven't explained, but the thing is that for multiple number of rows, sort keys will be help us in sorting. Okay, not sorting, by like arrangement, which record will go first, then second, then fourth, then fifth. This sort key, we will get that sequence using the timestamp. Okay, because time is always in increasing order. Timestamp will always get increased, so we will use timestamp as a sort key, which is the number. Perfect. Now we are done with this tab. We can close this and navigate to this tab, and in the table now I can see, I haven't seen anything. I can click on this refresh button. Alert 2 is there. I need to create a IAM rule, AWS IAM rule for this specific DynamoDB table. Okay, name alert 2, what role, create role, assigned attached to this. Okay, add action. We need to wait some time. After creating role, you can get this thing, but please wait some time. Okay, yeah, 2 or 3 or 5 seconds maximum. Now add action. You can see the SNS, with SNS action we have one more action, which is insertion the alert data into DynamoDB. I think it is clear, but is it updated? Yeah, it is updated. If you can see, it is updated. It is perfectly fine. Yeah, yeah. So similarly, I will add for smoke and water also. Okay, so that I am doing right now. Okay, let's see that. That's fine. Okay, so now we need to, okay, select this alert to role, add action, decided, updated. So we are done. So we are done with our fire, smoke, and water rules, which can trigger email, SMS alert, as well as store the data into alert to table. For now, I can see, if I explore the table items, I can see there is nothing, 0 items returned. But but I but if I actually trigger this using starting this script, okay, because I can see, let's uncomment this also and this one also. Let's send 3 entries in DynamoDB, this one, and this one. In this one, why this will make entry? Because the flame value greater than 300. Why this will make entry? Because smoke is greater than 500. Why this will make entry? Because water pressure greater than 1000. So okay, okay. So these all three scripts, these all three lines of code will run in the starting of the script once we are connected. Once this thing will be connected to AWS IoT. So let's run this. So we need to wait. Actually, it is sending three IoT. It is triggering the all the three IoT rules, and result of which we will get three emails. So 558, 590, 1236. And if I refresh this, if I click on this thing, three entries from Raspberry Pi as a thing ID of this partition of DynamoDB. Hopefully, hope you understand this point. Because these are very important in understanding AWS services. Okay, so we are done with, if I can see, we are done with this flow. In the above flow, we covered AWS SNS, we covered DynamoDB as well. Okay, so what is left? We already covered Timestream also. AWS Timestream, we already have the data storing in our database. So what is left? So Grafana is left. How are we going to set up Grafana and set up AWS Timestream data source in Grafana? Okay, so let's set up that. So in the search input box, you can simply search Grafana. You can see Amazon Grafana. This is the Grafana which is managed by Amazon Services, AWS Services. I will refresh this. Okay, let me do one thing. Display capture. Okay, not this one. Video capture. Yeah. So I have turned off the video for some time because yeah, perfecto. So I think my screen is visible here. I can see all workspaces. Okay, click on it. So IoT demo is one workspace which is already there with authentication as AWS SSO single sign-on and is created on 1st May 2022. Today is 15th May. So what we can do? Let's create one more workspace. Okay, let's do that. Create a workspace. IoT demo is already there. What should we name? IoT demo 2. Okay, IoT demo 2 in camel case tags. Let's save it. Click on next. Then what should be the authentication method when we are logging into Grafana? There are two things. AWS single sign-on. This is a simple thing you can enable this by creating a user. This new user does not automatically have access to the Grafana console. You will still need to assign this user later once the workspace is created. So basically, we need to assign this user, okay, to the workspace. Then only it can access the Grafana. So select this thing. Fail to initialize widget. The widget is required to configure SSO. So we need to please refresh the page to try again. Not enabled. So what we can do is refresh this page as it is suggesting. Okay, we are at step 1 again, and I can see this is the okay new demo, basically new console. Okay, let's leave this thing. Let's ignore this one. let's name it Grafana demo simply, not IoT demo. So it's already there. Grafana demo, Grafana demo, simple. So this is the workspace. These are a few steps you need to follow. Okay, select this one. Okay, so pressing it, enabled, perfect. Service managed or customer managed. So select service managed because this will we will automatically provision the permissions for you based on AWS services you choose in the next step. So this will automatically do the things in background. We don't need to do things manually for our users which are using this Grafana. You will see how I am doing this thing, and what do I mean by this. Because for now, I don't think you will understand this process at all. Okay, click on next simply. Current account, organization account. So use Grafana to monitor resources in your current account. Okay, so select current account. For this data sources, what we are using as a data source, AWS Timestream. Select this one. So Redshift Athena is also there. And notification channel, you already know that Grafana, we have that monitoring as well as notification things. So if we want the SNS topic, as Amazon SNS to get integrated with Grafana, we can select this. But in this session, we are not covering that. We are not covering notification in Grafana at all. Okay, so we will ignore this. Okay, click on next. Grafana demo. Hopefully my screen is visible. Okay, it is visible. Okay, now I can see space workspace details, AWS enabled, everything is fine, and create workspace. Yeah, we need to wait here. Yeah, workspace Grafana demo successfully created. Okay, I think it takes 10 seconds or 10 or 12 seconds. Not a problem. What is it saying? Is the same thing saying that user like SSO is there, but I need to create a user and assign that user to this Grafana workspace. Okay, pending user input. What I can do is assign a new user or group. Click on it. I can see Jignesh Kumar is already there. A user is already there, as I have already added this user. Okay, so the thing is that, okay, now I can't see him. So let's assign. Click on assign user. Okay, click on this user, assign user. Now it is assigned, but what is it? It is a viewer. It can only view Grafana dashboard, but I don't want that. I want this user as an admin. He can create dashboard. He can create rules, everything. He can create different charts, all those things. So select it and make admin. That's all. That's the thing you have to do. Okay. Yeah, sorry. So Jignesh Kumar as the admin now, and I can see if I have also received any email. I don't think I have received any email till this point. Okay, for this here, I can see. Okay, 9 minutes ago, these are notifications. Okay, so what I want to make you understand from this point is that for AWS sign on, in your case, you can add the user. Okay, so Jignesh Kumar is already added in my case because I have already gone through this step in my previous workspace. That's why I don't need to do that again. But in your case, you can add that user and email ID on which you will get Grafana access. Hope you get this point. So okay, so now what I can do is, the steps are actually, these are only the steps. So Grafana workspace URL. So simply click on this and we will navigate to AWS managed Grafana. What I can see is welcome to AWS managed Grafana and sign in with AWS SSO. So the user which you have created in SSO and assigned as admin, using the same user you can log in here. Okay, so I already got logged in. What is the reason for that? I don't need to add any email or password, because the thing is, I already have logged in to this user to the another workspace, so I don't have to log into this workspace as well, but you need to do the login stuff at your end. Okay, so that's all for this step. Now let's do one thing. Let's add the data source. Okay, so what kind of data source? Time stream. Select time stream. Okay, click on it. Data source added. Perfect. So here there is authentication provider workspace IAM role. AWS SDK default access is security. So you need to select IAM role. Default region. Select for me default region is, I can't see here my default region, but but I, okay, let me see. Uh, so for me the default region is US East 2. Okay, so that default region you can get in the AWS IoT also. You will get the endpoint. In this also you will see. For me this is the default region. Okay, so if I can navigate to this Ohio, this here it is selected. If anything else is selected for you, choose this default region accordingly. Okay, because after the correct selection onwards you will get the database list, which is IoT 2 for me. Table is sensor 2. Measures are flame, room, site, smoke, thing ID, water pressure. So there is one mistake from my end, that I have created the rule in wrong manner in the starting. But if you have added the rule properly, that I have changed, and you and change and shown you, so then in that case you will only see the data, sensor data only, which are flame, smoke, and water pressure. So yeah, so let's click on save and test. Yeah, data source updated, connection success. So we are successfully connected to our data source. So there is nothing we can do in this part of the project. Okay, basically not the project. In this settings page we don't have to do anything else. Okay, so what we can do now is create dashboard in Grafana. I can see add new panel, add new row, all those things. So what I want to do is create 3 gauge and 3 charts. 3 gauge, the the first gauge will show the last sent data from the simulator, from this IoT, no, from this node simulator. Okay, the last sent data in the gauge. The data of what? Thing ID, not thing ID. Flame, smoke, and water pressure. These 3 data I want to show. in that cage. So you for that I need to add a pane panel. Okay, I need to select gauge. Let's see table view. I can't see no data. I can see no data here. I want to say see last flame data. Let's name it as it is, as I have shown you in the demo. Last flame reading. Okay, last flame reading. Let's name it last. Okay, I can see. Spelling is wrong. Last flame reading. Okay, so what should you type here? What is this query that will give you the last frame reading? Because okay, so let me show you first what we have right now. What we have. Okay. So database, so table, describe table, so measurement, first 10 rows. Click on it. Okay. So this is the format in which we have the data. So we need measure name as flame for the last flame reading. Okay, and I need to order that by time. So if you are thinking that this will work, let me see, let me show you that query of mine. Order by time in decrement order. The last, basically the last will come if I make a limit on the decrement order of time. Hopefully you are getting this point. So if I will do this thing, if I remove my cursor from here, there is nothing, no data is selected, can't see anything. Because the thing is that the last data is not, like, it is not confirmed that it will be always flame data. Okay, so for that reason I can't do this in this manner. I need to use transformation, and for that I have one transformation which is called as filter data by values. Okay, in filter uh, match all, yeah, any, let's add a condition. Okay, I don't think it is working for me. Okay, it is not working for me. Let me do one thing. Let's make it compatible with larger screen size, like 1920 1080. Okay, so now can I click on edit condition? No, I can't. So there is some issue. There is some, so let's make it this way. Okay, it's not working for me. We can refresh this page, reload. So there is only 15 minutes now remaining for us to close this session. So let's add this one, time series. We are adding cage for showing the last flame data, last flame reading. I can say last flame reading. In the transformation step, I need to select the values, the measure name equal to flame. Okay, filter by values, values. Let's delete it. Okay, so okay, so why is it not showing? The reason is that we need to add the query first so that we have some data with us. Okay, so for that let's select example query. Okay, let's select this one. So let's remove this limit thing. Okay, I have removed. So there are a lot of columns with measure name. I am focusing on which measure name? Flame. I want the last flame reading. So I will focus on site measure name. Where is measure name? Measure name. is equal to flame. Okay. So now I'm seeing the data which has the measure name as flame. So these are all flame readings in measure value colon colon B. Okay. So now I think I can easily add limit on this data. Limit 1. What I can do is okay, let me check once what I have already done. Okay, order by time. Okay, noted. Okay, that is the important thing because I need this thing in increasing order of time, order by time. And if I remove order by time, and I don't need to do the limit thing at all. Okay, because the if I remove this table view, it's taking the last value only. The gauge by default takes the last value. If you give it a range of values, it will take the last reading. I think this point is clear for gauge in Grafana. That's all. Click on apply. So similarly, I will create last water pressure reading and last smoke reading. Select star from okay, order by time transform. Can see macros. If I can select it is what it is last smoke. Okay, I need to select this one also. Filter data by values, condition, measure name is equal to smoke. Okay, that's all. And now make it here and add one more gauge with the same SQL query for water pressure. For water pressure, filter data by values, match any condition, measure name is equal to water underscore pressure. Measure name equal to water. See, need to see flame or water. ERESSURE. Okay. ERESSURE. Okay, looks good to me. Is equal to water pressure. Limit 10. I need to remove this and order by time. Last water pressure. Apply. Okay, make it compatible size in the right side of my screen. Okay, so we have the cage with us, which was the part of the demo. But now what we don't have is time series. I want a chart. Okay, so the because motive of this project is to do some analytics out of this data. Okay, so how do I predict the future? Basically, predictive analysis. How do I do that? So I using the checking the uh, data stream, okay, flow of data, the trend of data I will see using the time stream chart, time series chart. Then only I can understand that in future the fire will be triggered or not based on certain conditions which we have tracked in past. Hopefully understand you understood this point. Okay, so this is what we are doing right now. For this is just for the predictive analysis. We can do this on the data using. There are a few plugins in Grafana for machine learning and data analytics. Okay, so what I can do now is, okay, I can take a query, example query, and modify it in such a manner. That's all. This is what we have. But last 6 hours, I don't want. I want last 5 minutes or not last 1 hour at least. Okay. So what kind of data is this? This data is not making any sense at all. But after I apply the filter data by values, condition, measure name, fire data, trend is equal to flame. Now this data is making sense, right? Apply it. Okay. This is for fire. Then similarly, I will take the conditions and add for smoke and water pressure. Let me add that smoke and water pressure. Add transform. Oh, before that, let's take example query. Okay, this limit transform data, filter data by values, condition with measure name is equal to smoke data trend. Let's take that smoke data trend apply. Okay. Now the last one is water. Okay, let's make it good in terms of UI. So last smoke reading is here, smoke data trend is here. The last reading I can see is 111, which is what it is showing here in the gauge. Okay, the similarly I will plot a chart for water pressure. So for that also, okay, so data as water pressure. Okay, so this is the trend of data for water pressure for last 1 hour. Apply it, make it in good shape, and I think I have ignored the water pressure trend light. Okay. I think it is still in. Okay, if it is not, okay, it is. I think it is running. Let's run it again. Okay, okay. As we have not uncommented these lines of code, it will basically affect our email. It will basically generate emails for these because these are sending out of range data, alert data. Okay, so now what we can do is we can use 5 second of refresh rate on this on these kind of dashboards. We have multiple more things in this. Okay, I can see here like drop here medium value. Okay, so that is all for this session. We have already covered each and every part of this project. Okay, and we have covered AWS IoT Core for collecting device data via MQTT protocol. AWS Timestream is a time series database for analytics. Grafana for the analytics and reporting part. Okay, and also the notification. Okay, so that's all for this session. If I don't, if you have any questions, okay, I will not reply any questions in this session. Okay, what you can do is you can type your questions in the comment section. I will check that and reply it if I get the time. Okay, so that's all for this session.